In the diagram, segment AE is tangent to the circle at point A, and segment DE is secant to the circle at point C and D. What is the value of x? The value of x is blank. Enter your answer. So I'm going to first notice that we have x in both of these positions. So I've got to decide which of these I'm going to use. So I'm just going to outline some lists. So we're going to find the value of x. Since we're not finding the distance of any of these segments, that's just our main goal, is finding the value of x. So the first thing that I'm noticing is that the segment AE is a tangent segment because it only intersects the circle at point A. And then segment DE is secant, that is also given, and it intersects the circle at D and C. So I'm looking for outside the circle, a tangent, and secant intersecting lines. So this is the equation that this is the theorem I would use, and I just wrote out the theorem, how I understood it. So the length of the tangent segment squared. Okay, well the length of this tangent segment is length AE, and that's going to be squared. So I'm actually going to insert an equation really fast so I can write the squared, and then that's going to equal the length of the whole secant segment. Well, the length of the whole secant segment is from E to D, so that's ED times the outside segment of the secant line, so that's E to C. So now by substitution, AE has a distance of x, and ED, since there's more than one term, I'm going to write it in parentheses. We had x minus 2 plus 5 by segment addition. And then EC is x minus 2. And I'm going to see if I can simplify anything. We have a minus 2 plus 5, or a negative 2 plus 5, so that's going to be plus 3. Since we have multiplication there, we would now distribute. So I'm going to actually jump over to my calculator. Whoops, that's not going to do it right. Make sure that your squared stays as a squared, because mine changed to a multiplied by 2. That's going to change things. So then they say to expand x plus 3 times x minus 2. We can click here to show our steps. And again, this FOIL is just an acronym on remembering how to distribute when you're multiplying a set of parentheses that have two terms in them. So the F stands for first, so x times x, which is here. O stands for outside, x minus 2, which is x times negative 2. And the I stands for inside, so 3 times x. And then L is last, 3 times negative 2 right there. So then we have x times x is x squared. Negative 2 times x is negative 2x. 3 times x is 3x. And then they combine those since they are like terms. So negative 2x plus 3x simplifies down to 1x. Again, remember that 1 is implied. And negative 3 times 6 is a negative 3 times 2 is a negative 6. So that's how they ended up with those terms. So then after they simplified or expanded that, that's where we ended up with x squared plus x minus 6 on this side. So then they said to subtract x squared plus x from both sides. They're doing this in one step. You can technically do it in 2 steps. You could subtract x squared first and then subtract x. They're just doing it in one step. So we'll talk through this. X squared minus x squared reduces down to plus a 0. And then we still have this minus. This is where it might be beneficial to do it in 2 steps. So these reduce down to 0. And then we have this minus. Again, there's a 1 implied, so negative 1 times an x. So that is a negative x right there. And then we're left with x squared. Again, this is a negative 1, so a negative 1 times x squared is going to be negative x squared, and a negative 1 times x is going to be a minus x. So that's just that part. So x squared minus x squared again reduces down to 0. X minus x again reduces down to 0, and then we're left with a minus 6. So that's where that minus 6 came from. So then again, divide by negative 1 because there's a 1 implied right there. So negative 1 divided by negative 1 reduces down to 1. Negative 6 divided by negative 1 reduces down to 6. So our x value is 6.